So, a simple example from the lecture about how we go from a word problem like this to finding some equations and then solving those equations. So it's that step which is quite hard about seeing a question and figuring out what maths you have to do to find the answer to that question. So, simple example here. We're given the area of a rectangle and the perimeter. Okay, and we're asked to find the length of its sides. Okay, so this is just working through that example. So, very good idea to draw your problem out. So we've got a rectangle. We know the information about the area, 6 meters squared. We know the perimeter is 10 meters. And the things that we want to find, so this is where we're adding information to our diagram. We want to know this parameter, the length, and the width of this rectangle. Okay, so we start to think about some equations that relate what we want to know to the information that we have. Okay, so we know that the area of a rectangle is just the length times the width, and that is equal to 6. And the perimeter is just the sum of all of the sides, so length times width, length plus width plus length plus width, which we can rewrite as 2 times length plus width, and that's equal to 10. Okay, we can simplify this equation a little bit more. We can divide both sides by 2, and that just gives us length plus width is 5 meters. So we should have probably put a little meters there. Okay, so you think now we've got two equations, this equation, and we want to solve for our two unknowns, L and W. Okay, so what we're going to do, first of all, we're going to try substitution. So we're just going to rearrange this equation here to get one of these variables on one side, in this case L. So we do minus W from both sides. That gives us just L on this side and 5 minus W on the other side. Okay, we can then take this expression here, so 5 minus W is L, so we can put that into this equation up here and say 5 minus W times W is equal to 6. Okay, same as this equation up here. Now this gives us one equation with one unknown, but that unknown appears twice. So we want to try and solve this equation for W. Okay, so start out by seeing if we can just get rid of these brackets here by multiplying everything out. So 5 times W and W times minus W is minus W squared plus 5W, and that's equal to 6. So you should now notice that this equation is of a quadratic form. Okay, so we've got the thing that we want to know raised to the power of 2 and the thing that we want to know raised to the power of 1. Okay, so this implies that we have to solve a quadratic equation. Okay, and you could kind of rearrange that to this form. It might look more familiar. All we've done is add or take away 6, from both sides. So that should be a minus here. Oh, so that's yeah. So we take away 6 from both sides, and what I've done here is then I've also times the whole equation by minus 1. So minus 1 times W squared is W squared plus 5W times minus 1 is 5 minus 5W. I've taken 6 from both sides, so this should be minus 6, and then times it by minus 1 to give plus 6. Okay, and the way we're going to go around solving this equation, so you could look at this equation at the top here, and you could try and find two numbers that would we would multiply together and get plus 6, and add them together, and we would get minus 5, and we could try and just think of numbers which we could put into this quadratic here to kind of like solve for each part of the quadratic equation. Okay, but we're actually going to go through this example by solving by the perfect square method. Okay, so if you remember that a quadratic equation will ideally, if you want to kind of like solve for the two brackets, you'll have x squared plus m plus n, or in this case m plus m, because this is a perfect square we're trying to create, plus m times n, in this case m times m, because we're we're trying to create a perfect square. So you could write that out as this describes a kind of like a perfect square quadratic equation where we've got 2m and m squared over here. So we want to make our quadratic equation kind of look more like this guy. Okay, so if we look at what in this guy, the thing in front of the x to the power of 1 is 2m. So in our equation, okay, so what I've done is I've just moved the 6 back over to this side, so I've minus 6 from both sides. This leaves basically a gap in here where we're going to put in, we're going to find a value of m squared that we can put in here to make this side of the equation a perfect square. So we know that this minus 5, that is equivalent to 2m. Okay, so minus 5 is 2m. So we can rearrange this little equation here to find m. So m is equal to minus 5 over 2. Okay, so that means m squared is minus 5 over 2 squared. Okay, and you could kind of like work that out if you wanted to, but kind of like minus 5 squared and 4 squared, and sorry, 2 squared, so minus 5 squared is plus 25. 4 squared is 4, so 2 squared is 4. So that gives us m squared is plus 25 over 4. Okay, so if we just add plus 25 to 4 to both sides, we end up with this term here. So this is a perfect square, okay, where our two sides of the perfect square are w minus, well, w, and then this part here is just m that we calculated here. Okay, so that gives us our one half of the equation, which is w minus 5 over 2 all squared. On the other side of the equation, we've got minus 6, and we've added this this 25 over 4 to this side, and we could kind of like add together these terms here. So we've made a common denominator. So 6 times 4, so 6 quarters, or 6 lots of like quarters, gives us 24 over 4 is the same as 6. So minus 24 over 4 plus 25 over 4. Just add through the top there, and that gives us 1 quarter. Okay, so we now have an equation here where we've got our perfect square is equal to 1 quarter. And then we just kind of solve that equation. So we square root both sides, so w minus 5 over 2 plus or minus the square root of a quarter. Okay, and then to isolate w, we just add 5 over 2 to both sides. Okay, square root of a quarter is a half. Okay, so half of a half is a quarter. So we've got plus or minus a half plus 5 over 2. So that's the same as saying if we add these together, we'll have 6 over 2. If we take this from this, we'll have 4 over 2. Okay, so that's the same as 2 or 3. So 4 over 2 is 2, 6 over 2 is 3. Remember to have the units in there. Meters again. We can also check our answer with our original set of equations. So for instance, length times width is equal to 6 meters, and we've got our width is either 3 or 2, which makes our length the other one. So we can times those together, we do in fact get 6. We can do the same thing for the perimeter equation and get 10 to check that we're getting the same answer. Okay, so that's a quick example of going through, starting with some words, figuring out what equations we have got, okay, so describing our problem in terms of equations, and then simultaneously solving those equations, and then ending up in this case with a quadratic, okay, which was a little bit tricky, and then we know that we can solve all quadratic equations using this perfect square method. So we use the perfect square method here, go through, find our answers, and quadratic equation will always have 2 answers, we should have 2 answers, and that then allows us to check our answers with the equations we started with at the beginning. Okay, end of that.